and welcome everybody to our webinar today about antenna placement and interference analysis in 3DEXPERIENCE. We will in particular speak about the antenna placement app today. What you will see is a mixture of a demo and even an online demo in the antenna placement app. Before I would like to start talking about the antenna placement app itself. Let's consider the topic of the connected aircraft or connected aviation. As you might know, the connected aircraft or connected aviation is a way to transform the way we communicate on and with an aircraft. It makes, for instance, flight safer by upgrading air traffic management systems. It allows for predictive maintenance. It improves fleet management, flight operations, and aircraft turnaround time. And it also reduces operational costs and offers more passenger entertainment. As you can imagine, all that relies on seamless high-speed connectivity in the sky, where wireless technology is one of the backbones of high-speed connectivity. And one of the key elements in establishing these kind of wireless links are installed antennas on aircraft, but also on other vehicles like helicopters, on satellites, etc. So what are now the aircraft antenna installation requirements? First of all, on the right side, you can see an aircraft which has a multitude of different antennas connected to RF systems installed on the aircraft. And first of all these antennas have to work in the intended environment, which means in terms of temperature, humidity, lighting, etc. All these requirements are specified in RTCR DU 160G. If we talk about electrical requirements for installed antennas, they also have to meet certain requirements, as there are the polarization, the VSWR, or the return loss, the power, the gain, and even the radiation pattern. Besides the electrical requirements, we have other requirements or other constraints which we have to meet, like aerodynamic, mechanical, and space constraints. And finally, as you can see, we have many systems installed on such an aircraft. We have to make sure that the interoperability of aircraft systems connected to our antennas is achieved. At Dassault Systems, or in particular at Simulia, we offer that kind of workflow here for antenna placement interference analysis in 3DEXPERIENCE. It has 6 different steps, but it all starts in the 3DEXPERIENCE platform. Or we start with some input to define some inputs. Okay, you can see my mouse now. So we have, for instance, aircraft CAD files, we have antenna specification, we have installed antenna specification, but we also have radio specification. Then we will do the first step, which means antenna design, not only antenna element design, but also antenna array design, feed network design, radome design, etc. And then once we have an antenna, we need to have a platform, which would be the aircraft in that case. Here we can apply some idealization, defeaturing, parameterization, define materials, and also define some antenna locations. Then the third step would be already the antenna placement, which is then, specified in terms of some KPIs, antenna placement, antenna patterns, and antenna VSWR. And finally, the fourth step, we're talking about cosine interference. We do some cosine interference analysis. Fifth step, which we might need to achieve the cosine interference, is to design some microwave and RF components like transmission lines, but also filters. And then the last step is already the design verification, where we check performance against specification. And then, of course, at the end, we come out with some outputs in terms of antenna CAD, antenna location, but also component CAD. Today, we will not talk about the entire workflow. We will, in particular, focus on the 3 steps which are highlighted here. To prepare the 3D antenna model, to prepare the 3D model, the antenna placement, and the cosine interference. As I mentioned at the beginning, we offer a dedicated tool. We have the antenna placement app, which allows for placing antennas for optimal electromagnetic performance on vehicles like an aircraft, but can also be a car, can be an eVTOL, can be a satellite. So it's not limited to aircraft. That app allows for an early validation of antenna performance and location even before the first prototype of an aircraft is available. It allows to avoid interference and costly late stage failures. It comes with a very easy-to-use interface for system integrators in a collaborative environment, where the collaborative environment is our 3DEXPERIENCE platform. It allows for traceability of model updates, which means if a CAD designer is changing something on a CAD model, it will be also reflected in the antenna placement app. And finally, we offer performance trade-off analysis in a dashboard. So we decided today to come up with a number of colleagues. So we are going to present with 4 people today, and we assigned to each of us different roles, as it would be the case in a real environment. So my task will be today the project management. So I will talk and present to you project and requirements management. Then we have Naomi, who will play the role of a CAD designer. She will talk about aircraft modelization. Then we have Harvinder, who is taking the role of the electromagnetic simulation specialist. He will talk about antenna installation, simulation setup, and coverage analysis. And then we have Carlos, who is taking the role of the RF systems engineer and talking about interference analysis. And as you might imagine, we are not located at the same place. So we're really demonstrating something which is where we have accessing all the same data on our platform, but we are located in different places around the world. So myself, I'm located here in Hamburg in northern Germany. Then we have Naomi, who is located in Pune in India. We have Harvinder, who is located in Darmstadt in southern Germany, or in the center of Germany. And then we have Carlos, who is located in Valencia in Spain. So let me now move into our platform, where we have prepared a demonstration. So I mentioned already the topic before. We're going to talk about antenna placement and coarse interference on an aircraft. Our test vehicle here is the Spirit of Experience, which is our own built aircraft model in industrial systems. And in particular, we will place a VHF antenna on top of the aircraft and a glide slope antenna on the bottom of the aircraft. That flowchart you have seen before. In particular, we have different topics to cover, starting from modeling, pre-processing to simulation. We will talk about aircraft modelization, then the antenna integration itself, and finally about the interference analysis. Okay, now let me talk about the project and requirements management. And during the entire presentation, you can see on the left, you can follow the flow of our presentation always on the left side, and you can easily understand where we are and what we are talking about. So first of all, project and requirements management. Let me rewind the video here. And so the first step in that kind of analysis or project of antenna placement would be to define to create a new project. So we have a new project here, antenna placement, and then we can create and assign a new task. In that case, for instance, the first task would be the aircraft modelization. Often an aircraft model, a CAD model, is very complicated. So we do not need all the details for the simulation of the antenna placement. So we need to prepare it a little bit. Then we can create another task here to select the aircraft model, VHF, and glide slope antennas. And once we have created all these tasks, we can also define some dependencies among these different tasks. So which one is first, which one is second, and so on. We can assign it to different colleagues. And then we have a multitude of tasks here. And then you can even monitor the progress of the different tasks in that view here. We can put it into work. We can have it completed. We can again change the life cycle and so on, as you can easily see here. And then we can also again check the task schedule and dependencies. It's then shown here and again here.